Now this illustration deals with ambient temperatures in accordance with NEC 310.15, C as in car 1. Now mainly the ambient temperatures we're talking about here are based on 4 or more current carrying conductors in a raceway. Now I know as a designer, installer, a maintainer, or inspector, you look at this illustration and you say, man, that's busy. Well, we recommend start at the service. So at the service equipment, you have your overcurrent protection, circuit breaker, or fuses. And you're looking at if it's a branch circuit, you're looking at 210.20A for the overcurrent device sizing. 210.19A1 and B to size the conductors to terminate to the overcurrent device. And 240.4B where you could round up if you wanted to. We go to 240.6A, which would refer you to table 240.6A to select your overcurrent device. And the selection of the conductors terminated there would be 310.16. Now the conductor sizing, notice it's 210.20A for the overcurrent device and 210.19A1 for the branch circuit. But if that was a feeder circuit, it would just be 215.3. And then it'd be 215.2A1, A or B, see. And if you was at the service conductors at the left, 230.42A1 sizes the conductors. 230.90 with exceptions would allow the overcurrent device to be sized at the service. Now next, look at the adjustment factor. We would have table 310.16, and if the conductor was a 90-degree C conductor, we could use that to derate back to 60 or 75-degree terminals, as previously mentioned. So we're looking at 310.15C1 for adjustment factors, 4 more current carrying conductors in the raceway. But if you were routing it through a higher temperature than 86 degrees Fahrenheit, and basically speaking, by the approval of the authority having jurisdiction, 10% of the run, or they could hold you to 10 foot, whichever. Now, 310.14A3 informational note 4 deals with 4 more current carrying conductors in a raceway. That's why engineers, contractors, and electricians that know what they're doing would say that 310.14A3 informational notes 1 through 4 is the golden rule when determining the ampacity allowed on a conductor. Now, if you're paralleling, we're going to 310.10 G mainly, 300.5I, 300.20, and table 250.122F. Now that takes care of conductor sizing, it takes care of neutrals, it takes care of the equipment grounds in parallel, which we really went over real good in our chapter 8 and 9 to volume 1 to Stallcup's design book. Look at the correction factors. Next, table 310.16 gives you the ampacity based upon the insulation on the conductor. 310.14A3 informational note 1 gives you the information for correction factors. 310.14A2, when you look at the exception there, that if you're Y, that kind of determines if you're how you load the circuit, if it's current carrying or not. The 10% rule that you would apply, or the 10 foot. Now moving over to the conductor insulation to the right, you're looking at 310.4A, and that's the table 310.4A. You're looking at 310.10A, B, and C for wet, damp, and dry type locations, say. The conductor color coding or identification means is 200.6A and B, 200.7 A, B, or C, and 210.5 A, B, and C for branch circuitry, and 310.16 A, B, and C when you're dealing with conductor procedures for ampacities. Now, the conductor ampacity is table 310.16 and 310.14 A1 and B. Now, you can see here in this illustration all the important information referencing the designer, installer, maintainer, or inspector to sections that will aid them if they need these sections to help them along with ambient temperatures in accordance with figure 14-16.